The probability of it is B3, it is from machine 3, given that it's defective. And what we do, we are using the bias rules, which says it is equal to the probability of A given B3 multiplied by B PB3 divided by the summation of I from 1 to 3 of probability of A given BI multiplied by probability of BI. Now, here we know all of these terms. Probability of A given B3 is 0.2, sorry. Probability of B3 is 0.25. Now, probability of A given B1 multiplied by B1. So it is 0.02 multiplied by 0.3. Plus the probability of A given B2 multiplied by probability of B2. So it is 0.03 multiplied by 0.45. And the probability of A given B3 multiplied by probability of B3 is 0.02 multiplied by 0.25. And if we calculate it, the posteriori probability that we calculate is 10 over 49, which means approximately 0.2. The addition of the posteriori probabilities is equal to 1. In other words, the addition, the summation in here, the summation of PBR, R from 1 to K of A is equal to 1. The summation of the prior probabilities is also 1. Let's do one more example. We'll do two more examples on this topic. The same company has updated their machines and now they produce 30%, 30%, and 40% of the products respectively. So B1 this time produced 30, B2 produced 30, and B3 produced 40%. It is also known that some of these products are defective. And we call it event D. And we know probability of defective given that it is B1 is 0.1. Probability of defective given that it is B2 is 0.04. And probability of defective given that this is B3 it is 0.07. Now, the question is that find the probability that the product from B1 is defective. Okay, it's similar to what we did. I want you to do it. Let's put it this way. This is part 1. Part 2. R events B1 and D independent. Find the probability that the product from B3 is defective. Part 4 are events B3 and D are defective, are independent. A reminder, if A and B are independent, it means that Abdullah is the probability of A given B is equal to if A and B are independent, probability of A given B is
probability of
A. Or we can have this conclusion also. Probability of A intersected by B is equal to multiplied by probability of B. Okay. Think about this and tell me what are the results, are they independent? Yes, kids. Are B1 and D independent?
We should calculate.
Yes, I know it's very difficult and too much to ask, but here, look, in part A, I want you to calculate the probability of B1 given D. And then you check if it is equal to probability of B1. And if the answer, well, this is part A. And after you calculate it, you just see if this is the same as the probability of B1 was 30%. If they are the same, then you say that they are independent. In here, you have to calculate probability of B3 given D. And then you check if it is equal to probability of B3 for this part. Yes, Raymond. Are they independent, B1 and D?
B1 and D? No, they are independent.
They are dependent.
Yes.
What about the B3 and D?
Well, the results is the same. It's about 40%, but
Then they are independent.
they are dependent.
Independent. So, what we do, maybe you want to come and solve it.
Is there a possibility that those
No.
results are the same, but they are still...
Well, I mean, you will see that you can check this one and you get the same result. So, if they are the same, we call them independent. Or at least we can use that it seems that they are independent. You can write just the result, people can put the numbers. which is not equal
Which is
to,
not equal to 30%.
yeah,
But in case of B1,
write it down, it is not equal to
it's not
percent, so
Which is-
absolute. Depend.
Well, yeah, there was all,
This is B1.
this is B1, all this. Mistake. And about 3B3, the probability U and D would be well, the same formula that the result would be. Well, precise, that's pretty precise.
So put precise, don't put it that way.
And so they are
Independent.
in.
The numerical calculation, I think they have different stuff.
I got the same results.
Again?
Yeah, the same as his. Maybe we do it. Which one? On the denominator?
Yeah, and never mind the numerical.
Let's see. The probability of D given D1 is 0.1. The probability of B1 is 0.3. So their multiplication is 0.03. Probability of D given B2 is 0.04. The probability of B2 is 0.3. So you get 0.012. And the probability of D given B3 is 0.07. And probability of B3 is 0.4. And it is 0.028. And if you add it,
Okay.
we get 0.07.
Okay, the addition.
Yeah, I mean, don't trust your calculator in your addition. Use your finger, it's easy. Let's do one more example. If the question was asking that if they are independent or not, one way is checking by using the conditional probability, or you could, if you know what is the intersection, you can directly use the intersection formula. Now, let's do another example. And the example is, we have two coins. We call it coin A and coin B. And these coins have these properties. We have two coins with the following properties. Coin A, it's a fair coin which is 50% head and 50% tails. And we have a coin B, which is a biased coin, so it's 75% head and it is 25% tail. Okay? You select coin A or B with, let me reword it. Sometimes this sentence I write in this form. You select coin A or B with equal probability. Sometimes we write it like this. Selection of any of the coins is equal probable, which means that they have the same probability of choosing. There is no priority to choose coin A or coin B. You toss the selected coin and get heads. What is the probability that you had selected coin B? Now, we understand that in most probability questions and or in most computer science questions which we want to solve it by using the probability, if you be able to understand the scenario, like if you be able to write down what are knowns and what are unknowns, then 90% of the situations we can easily solve the question. So most of the time what happens, the students fail to understand what are knowns, what are unknowns in our hand. Okay, think about this one for a few minutes, and then I will solve it for you. Do we have any question about the solution of previous example? So I will write down on the board for us what are the known terms. No need to solve it, just write down what are known terms.
Probability of getting head for coin A.
Write it down. Okay.
How to, I don't know, sign it.
I don't know. How many heads do we have in general in the question?
Two.
Yes, the head can come based on two situations. So it can be head if the coin is A, right? And it can be head if the coin is B.
So it's even, like.
It's like, exactly. It's probability of head given the coin is A, B, it, what else? There are two more numbers. Given A, yes. What else do we know?
So when we say fall, like
Very good. What else? Very good. One more thing before you go. What is the question? What do we need to calculate? Very good. Thank you. So the question is that what is the probability of having coin B if head has happened? So what is the probability of coin B if head has happened? And we know that for coin A we have this probability for head and tail. For coin B we have this probability for head and tail, which means that the probability of head if the coin is A is 0.5, and the probability of head if the coin is B, which is the bias coin, this is the value. So what we need to do, we need to see what is the probability of B given head, which is, Abdullah, do you want to try? Okay, the other part of the board. Do you mean this is equal to that, or this is equal to the whole term? Do you mean this?
Okay.
Yeah, okay. Mhm.
Probability of
Very good.
we only consider head.
Yes, we only want to have heads, right? So this is equal to, let's put the numbers, 0.575 multiplied by
Head given.
5. No, why is 0.25?
Probability of
Head
head
given A.
given A. And probability of
0.5. So it's equal to 0.75? 0.75? Now I tell you, right,
this is
0.75 divided by,
yeah.
no, just write what I tell you. Calculate
Okay.
is equal to 0.75.
I've seen that this.
No, right, 0.75 divided by 1.25. 25.
Yeah.
3 over 4. That one is 5 over 4. So it will be 3 over 5. Yeah. 0.6. Very good. Thank you very much. Do you have any question? Agils?
So I see that we changed the formula, like in the bottom side.
No, the formula is this, the probability of the whatever event we want to have, given that, I don't know, BI, wasn't it like this?
Yes.
So here we have head of B and head of A.
Okay. Yes.
So still-
It's okay.
And your handwriting is very bad.
I know.
If you have no question, this is the end of the lecture for today. I will see you next week on Thursday, because when